we're going to start talking about other types of sound interference. In the last few videos, we've been talking about standing waves, which is multiple waves that interfere with each other, creating a resonance frequency. Now, we're going to talk about other types of sound interference, where it doesn't produce a standing wave, but it does produce some interesting audible effects. In this video, we're going to be talking about the synthesizer. Now, why do different objects sound different? We'll talk about specifically why does it, we'll talk about musical instruments because it's easy to talk about. Why does a trumpet sound different from a flute? The answer lies in the overtones that are possible. Which ones actually sound in the instrument and how strong each particular overtone is. Here on the left, you see three figures. On the top is a clarinet, middle a piano, and on the bottom a violin. A clarinet, you are going to get, let me get my laser pointer here. You're going to get a pretty strong manifestation of the fundamental frequency. But a clarinet is a clarinet is a closed tube, which means that there is no second harmonic. The second even number harmonics don't work in a closed tube. So you have your fundamental frequency, your third harmonic. When you play clarinet, the third harmonic does sound, but it's a lot quieter. You have the fifth harmonic, which is much quieter, seventh harmonic, much quieter still, ninth harmonic, 11th, 13th, so on. Now, when you play let me come back and talk about a flute and then come back to the clarinet. When you play a flute, you get the fundamental frequency and that's it. So if I were to play a flute that at, let's say, 600 hertz, you would get, that would be the sound that a flute makes. Just a simple, straight tone. However, when you play a note on the clarinet, you get all of these overtones playing, or all of these other harmonics that also resonate inside the tube. And so what I've done here is I've opened up multiple tabs, and each tab has a different harmonic of a closed tube. So we're working on 200 hertz. So the third harmonic would be 3 times 200, which would be 600. The fifth harmonic would be 200 times 5, which is 1,000. The seventh harmonic would be 200 times 7, 1,400. The ninth harmonic would be 9 times 200, which would be 1,800, and the 11th harmonic would be here. And if you notice the volume bar down here, I've adjusted the volume to more or less represent the amplitudes that you have here in this figure. So again, if I just play one single tone, that would be like what a flute experiences. But in a clarinet, you also have overtones. And that's the sound that a clarinet would make. More or less what it sounds like. And what we can do is we can do this type of analysis for each instrument, program it into a database so that whenever you play a certain note on a synthesizer, it plays the same harmonics and thus reproduces the sound of a clarinet or the sound of a piano or the sound of a violin. And so that's how a synthesizer works, is by using the overtones that are present in an instrument.